Today we are going to talk about geometric sequences, and in the last lesson we discussed sequences and series, so we're just moving on to type here. Many definitions that you would probably guess. First, a geometric sequence is a sequence where the ratio of a term to the previous term is constant. So meaning that the second term divided by the first term would equal the third term divided by the second term would equal the fourth term divided by the third term. So you're taking the one after, dividing it by the previous. Whatever you get should stay constant throughout. We call that the common ratio. So in arithmetic sequences, we had a common difference. Now we have a common ratio. So that will be one thing that'll be a little bit different in the formulas that we had for arithmetic. We had a D. Now we'll have an R, which stands for the common ratio. A geometric series, similar to an arithmetic series, it's just an expression that we form when we add together. So by adding the terms of a geometric sequence. Just like arithmetic sequences and series, there's a specific formula that we can use to write our rule. So not all sequences and series are arithmetic or geometric. There are many that are neither of those. So just because we're learning some rules doesn't mean that there's always going to be a specific formula for a rule. If we get lucky and it happens to be arithmetic or geometric, we have a formula we can plug into. Otherwise, we have to do what we did in 11.1 and just use our logical reasoning to hopefully come up with the correct rule. So the formula for the rule for a geometric sequence is a sub n equals a sub 1 times r, which is the common ratio, raised to the n minus 1. A1 again stands for the first term, just like it did in the last lesson, and r is the common ratio. Now, when you have a summation, the rule for the sum of the first n terms, and again this only works for finite series, you're going to have first term times 1 minus common ratio to the n divided by 1 minus common ratio. So formulas to kind of use each time in order to find the sum or find the rule. So first thing you need to be able to do is to look at a sequence and decide, is it arithmetic, is it geometric, or is it none of those? Because that's going to help you decide how to approach writing rules. So I've got 3, 9, negative 27, negative 81, 243. So what I need to do, because remember, I need to look for both to see if it's ratio or if it happens to be different. So I'll look for ratio first. So the common ratio, 9 divided by 3 would be 3. Negative 27 divided by 9 would be negative 3. So I can see after just two of them that it's not geometric. So now I'm going to look and see if there's a common difference. 9 minus 3 is 6. Negative 27 minus 9 is negative 36. So again, we only had to do two. We got a ratio that was not common. We got a difference that was not common, which means that this one is neither. Our explanation is that there is no common difference, no common difference or common ratio. So neither of those exist. So now let's look at the next one. So I'll look at ratio first. Negative 8 divided by 4 is negative 2. 16 divided by negative 8 is negative 2. Negative 32 divided by 16 is negative 2. So here I got the same thing, which means it is constant. So that means that this one is geometric because there is a common ratio of negative 2. All right, example 2, write a rule for the nth term of the sequence, then find a sub 7, so the 7th term. All right, so I look at this and first I want to make sure that it fits into this rule. So is it geometric? So negative 6 divided by 1 is negative 6. 36 divided by negative 6 is negative 6. Negative 216 divided by 36 is negative 6. So it is geometric. There's a common ratio of negative 6, which means I can go ahead and use my geometric rule. So a sub n is going to equal a sub 1, first term, which is 1, times r, which we already just found. R is negative 6, raised to the n minus 1. So I always need to simplify. The only thing that needs simplified here, because obviously I can't do the power because I've got a variable, 1 times anything is just itself. So we're going to simplify that to just negative 6 to the n minus 1. So there's my rule. Then it also asked me to find a sub 7. So that means find the 7th term. So a sub 7 equals negative 6 to the 7 minus 1. So I'm doing negative 6 to the 6th power, which is very large. A sub 7, believe that you should get 46,656. So I've got my rule and I've got my 7th term. Example 3, write a rule for the nth term of the geometric sequence. So still writing a rule, but here instead of looking at the sequence, I actually have some of its information. So it's telling me a sub 4 equals 3. So again, that means I'm going to plug it in here. If a sub 4 is 3, that means 3 equals a sub 1 times r, which they told me was 3, raised to the n minus 1. So when I look at this, a sub 4, I can plug in 4 for my n because I know what term number it is. So I put a 4 in here. So I've got 3 equals a sub 1 times 4 minus 1 is 3, and 3 to the 3rd power is 27. So to get a1 alone, divide by 27. These cancel. 3 over 27 is the same as 1 over 9. So I now know that my first term would have had to be 1/9, which means I can write my rule now. So a sub n equals a sub 1, which is 1/9, times r, which is 3, to the n minus 1. Now, I want to caution you here. Please, please, please do not ever try to multiply this times this. Order of operations says you would have to do exponents first, which we can't do here since there's a variable in it. This 3 is a base. It is not a constant. If there were a constant number in front of that, we could combine it with the 1/9. But you can't combine this 1/9 with the base of the power. So this is all I can do here. 1/9 times 3 to the n minus 1. All right, next one. It says a sub 2 is negative 4, and a sub 6 equals negative 1,024. So I can plug both of those in. So that means negative 4 equals a sub 1 times r to the 2 minus 1. and negative 1024 equals a sub 1 times r to the 6 minus 1. So if I simplify this, negative 4 equals a sub 1 times r. This one, negative 1024, equals a sub 1 times r to the 5th. Now, the last time we had this where they gave us two different terms of the sequence, we solved it using a system of equations, which is the same thing that we have here. I've got two different variables, two different equations. However, I can't just use an elimination method here because these don't have pluses and minuses between the variables. So the only way that I'm going to be able to solve this is if I use substitution. So because they both have an a sub 1 that is plain, meaning it doesn't have another exponent on it, I can solve for a sub 1 in this first equation. So that would be very simple to do. If I want to get a sub 1 alone, I would divide both sides by r. These would cancel, and so a sub 1 equals negative 4 over r. So hopefully we can all agree on this fact. If that is true, that means that I can take this negative 4 over r and put it in here, in place. So when I do that, I get negative 1024 equals negative 4 over r times r to the 5th. Now r to the 5th, it doesn't have a denominator, which means its denominator is 1. And look what happens now. I've got r to the 5th in the numerator and r down here. These can reduce. This becomes r to the 4th. So I've got negative 1024 equals negative 4 r to the 4th. So divide both sides by negative 4. That gives me 256 is r to the 4th. Now we undo a 4th power with a 4th root. So 4th root both sides. And r equals technically plus or minus 4. However, they can't both be right there. We'll take the positive version of that. So our common ratio is going to be 4. So now that we know that, we can write the equation. So I go back in and I say my rule, a sub n equals then a sub 1, which I suppose I should probably find. So a sub 1 here, if I plug back into this equation, negative 4 equals a sub 1 times r, which is 4. So divide both sides by 4, and a sub 1 is negative 1. So this is going to be negative 1 times r, which is 4, raised to the n minus 1. And you could also just write it with the negative outside the parentheses. That would be okay as well. All right, that one kind of took over a little more space than I wanted to. All right, to example 4, given the series, find the sum of the first n terms and then find n for the given sum. So I've got two different situations here. So here I'm told that n is 10. Here I'm told what the sum is. So when I'm looking at this series, I should probably find the common ratio. So 2 divided by 4, the common ratio is 1/2. So that's r. Now, here it's telling me that n is 10. It wants me to find the sum of the first n terms. So I'm going to be using this formula up here. So s sub 10 equals a sub 1, so 4, times 1 minus r, which is 1/2, to the n, so to the 10th, over 1 minus r. And now I have to simplify this. Again, your calculator can certainly help you to do that, but you have to be careful about making sure that you're telling it to do the right thing. So here, when I do 1 minus 1/2 to the 10th, make sure that you do that separately or use parentheses before you do this 1 minus 1/2. You should, when you simplify this guy right here, you should get 1023 over 512 when you use your calculator's fraction button, which means when I multiply this is like 4 over 1. In simplest form, because we're going to reduce the 4 with the 512, I get 1023 over 128. So again, use your calculator to help you, but make sure you use an appropriate amount of parentheses if you want to get this answer correct. All right, so in B, a little bit different because now we're given the sum and trying to find what term number it was. So sum equals, so 31 over 4 equals a sub 1, which is still 4, times 1 minus 1/2 to the n is what I'm solving for, I don't know that, divided by 1 minus r. So to simplify this guy here, first I'm going to do this 1 minus 1/2 over here, which is just 1/2. So I've got 4, I've got 1 minus 1/2 to the n, which I can't simplify because of the variable, and this is 1/2. So what I can do next, dividing by 1/2 is the same thing really as multiplying by 2. So instead of having the 4 divided by 1/2, I can have 4 times 2 and get rid of this denominator here. So I can make this 31 over 4 equals 8 times 1 minus 1/2 to the n, and I've gotten rid of my denominator there. Now I can get rid of it, so I'm going to divide both sides by 8. Dividing by 8 is the same as multiplying by 1/8. So 31 over 4 times 1 over 8, I'm going to get 31 over 32 equals 1 minus 1/2 to the n. So subtract 1, subtract 1. This should be fairly easy to do because you know it has to have a 32 as a denominator, and that's negative 32 over 32. So I get negative 1 over 32 equals negative 1/2 to the n. Now, it's important that you realize where the sign came from. If you look at the original, it's not negative 1/2 to the n, it's minus 1/2 to the n. And that matters. They're two different things. So here, if I want to solve for n, I can go ahead and divide both sides by the negatives and make them both positive. So I can make this 1 over 32 equals 1/2 to the n. Now this one is probably, you could log both sides, which is how you get rid of exponentials, but this one's probably much easier to solve with guess and check. What power of 1/2 gives you 1 over 32? It's essentially just asking what power of 2 gives you 32, because you know the numerators are the same. And that answer is 5. So n has to equal 5 because 1/2 to the 5th power would give you 1 over 32. All right, last one, example 5, find the sum of the series. So now we're finding the sum given summation notation. We can still use this same formula. So notice that the top here is 10, so I'm finding s sub 10 equals a sub 1, so the first term. Well, the first term, it says we're starting at I equals 1. So 6 times 2 to the 1 minus 1. 1 minus 1 is 0. 2 to the 0 is 1. 6 times 1 is 6. So a sub 1 is 6. So I can plug that in. Then I've got 1 minus r. Well, you know that r, when you're looking at the rule, is going to be whatever is in here. Now, if you didn't know that, you could find the second term and then divide them. So if you wanted to find a sub 2, so 6 times 2 to the first, which is 12, and then say 12 divided by 6. So if you didn't just know to look at the base, that's another way you could figure it out. But I think most of you can probably look at that and say, I know that the common ratio is whatever the base is here. So this is going to be 2. 1 minus 2 raised to the n, which is 10. And then on the bottom, 1 minus r. So now I just need to simplify. I've got 6. This is just negative 1. So that just means I'm going to make this negative. So negative. And then I've got 1 minus 2 to the 10th. So essentially negative 6 times 1 minus 2 to the 10th, if you use your calculator, should give you 1,023. So times the negative 6 gives me a final answer of 6,138 for my sum. And again, if you had the time, you could always add all 10 of those up and check your work. So multiple ways to come up with the same answer, multiple ways to check your work there. So that is your math for today. Gratata.